Hi, I'm in the construction in the field report. So, field report. And here we go.
Bring in the concrete guy. He starts the footing and foundation. Afraid to follow him or along with him as we do the footing into the ground. We may have speed footing. Yeah, different kind of work. Electrical, stormwater, see right here? There's a sleeve in the wall. That's a sleeve. That's a hole. Put in the wall. Put a pipe in there later. The pipe right there will go to a Filterra unit, which is a stormwater unit that will hold water before it's discharged back into the ground or out in the stormwater system.
So is the bearing the blue part?
The blue part is the waterproof.
Just the bearing underneath that?
Bearings all the way down. So I'll show you right here. We have a situation I can show you.
I got a question.
Yes.
So, with like all the exposed metal, with like the temperatures and like the rain and stuff, do y'all like spray it with like something to like kind of protect it from rusting, or is
So
it built into the metal?
it depends on the project specifications. Here, it's just all ferrous metal, meaning there is no paint or anything. It's the rust will protect that. Also, if you ever have spray fireproofing in a project, spray fireproofing cannot be applied over primed painted steel. So here we have spray fireproofing. So at some point in the project, we'll come in once we're dry, and they shoot on this fireproofing over top of the steel. So whenever you see a building like this where there is no paint on it, most likely it'll be fireproof.
See, what it means is that fireproof is a time in case there is fire in the building. You give 2 hours for people to be evacuated so that this structure will not collapse. So that's why they have to spray it. You understand? Because like in the World Trade Center, you see that how everything collapsed. So there is what we call cover for fire, so that in case there is any fire, people can move out within 2 hours and the building will not collapse, because all these things are the one carrying the building. So that's why you have to do the fire coating, fireproof, to ensure that at least for some time it can still stay. The heat will not penetrate into it. You understand? So, and then they were talking about environmental site design. It's very important that when you are doing a new development, when there is rain, like how do you make sure that this water is discharged off, and then the water that you are coming out from your new development, you don't just want to discharge it to the JCP Bay with all the contaminants. So you have to treat the water. So sometimes everything now goes into the sewer. Sewer is those one that carries the wastewater, maybe from the site and all those things, and must be eventually done. Then it was talking about waterproofing, because you don't want water to be going into your foundation. You see, some of you that have basement, you see that sometimes your basement is flooded. So sometimes what they do outside, they put some sunk pumps. But here, it's being waterproof. There are some waterproof membrane, like they use bitumen from Saudi Arabia. It's from oil. You see that bitumen is from fractional distillation to do the waterproofing. You understand? So thank you, sir. So you can start with this.
Yeah. Also, with regards to putting water into the environment, during construction, we have sediment control to maintain. We talked about that Filterra, which is something at the end. But it's very important that I don't track all this mud out on the street. I'll get yelled at for that by environmental. So we have this wash rack right here. So there's that metal rack you saw where they get as much mud off their tires as possible. And then we'll wash the tires down before they go. And then within the site, we have silt fence of different types. You see that black fence over there? That keeps water from going off the site in a contaminated condition. And there's various types of silt fence, silt diversion, but that's just one of them. used heavily by the masonry contractor and a lot of times to move materials to the higher part of the building. This piece of equipment happens to be my concrete subcontractor, and he just moves equipment and materials around over the site with that piece of equipment.
What's it called again?
A shooting boom forklift. They are rated as cranes are with their ability to pick weight. So on the forks on the front of that thing, by shooting boom, the front of that thing will keep projecting out. So they can, like if I started right here, I could shoot the material out into that building so they could land it on the deck. That happens to be one of the heavier machines. They have outriggers on the front. You see that arm that sticks up like that? In order to project the material far out, they can put those arms down in order to keep the machine stable.
You will see that if all of this equipment at the back of it, we have the counterbalancing load. You see, so that to prevent the overturning, you see all of them have very heavy counterbalancing because it must be at equilibrium. So when the boom is stretched out and is carrying a load, the moment about this fulcrum must, so this other movement, if you multiply that, is that this one is clockwise and the one going this one is anti-clockwise, so it's called the counterbalancing moment. So therefore this must be greater than that. If the turning moment, which when the load is, that's why the load has a capacity, you must not exceed it, or else if the clockwise moment is greater than the anti-clockwise moment, the thing will overturn. You understand? So this is you are going to see when we get to all this equipment at the back of it, very heavy. It's a very low, and that's what determines the capacity. And then it changes as the boom length changes. You understand? Because moment is load times moment arm. So the moment will increase as the boom length increases. So the operator must know that as the boom length is increasing, the capacity decreases, or else everything will tumble.
And in each piece of equipment, they're all locked, as it should be. There'll be a load chart in that equipment.
Yes.
They'll take the weight of whatever load they have, the rough weight, and they'll be able to take that and the distance they want to move it and verify on their load chart before they make any picks or moves.
Do you understand? Because the chart we have, okay, if the boom moves about 10 feet, this is the maximum weight it can carry. If you move about 20 feet, the maximum weight reduces because the moment arm is increasing. Do you understand? So that is how the application of all those things.
Concrete subcontractor. This is what they use to dig the footings. Again, that will have a load chart. Which you can actually see through the window right here. That will give him the orientation on this piece of equipment. It's important how your cab is over top of your tracks. So it can be made just like you see this machine. If they're sitting to the side, the machine can upset rather easily. So the amount that they can pick up weight-wise is substantially decreased if they're on this side. So the heaviest they can do, whatever the max on this machine is, will take place right out there over the front of the machine.
So this is called an excavator?
Yeah, this is what they
If you
dig
look
the
at the
footings.
back,
The
you see that the counterbalancing to counterbalance,
footings, they can dig the foundation. It's just a
and this can swing 360 degrees.
yes, 360.
So it can swing 360 degrees, and the maximum is when it is at this parallel side like this, because as it swings away, it's the maximum load which it can excavate or we can work on reduces. Yes.
The swing, does it have a swing? We were talking about the crane, and it had a swing pin. The swing radius, does that have one as well, or it's low for them?
It does. As far as the swing and the load and everything we were talking about,
Yeah.
the weight, there's a chart right inside this machine that actually will tell them what they can and cannot do. I'll be honest, most of the guys don't refer to the chart, they just refer to their experience and what they can do.
Be careful.
See, fortunately, it's not real muddy out here because of the soil amendments we've done. When we put the Portland cement in this ground, that tightened up the ground, so you'll get a slick surface of mud on top, but it doesn't matter. The heaviest piece of equipment you want to drive here, 14 inches thick actually by design. But underneath of this footing, just in this small area, I poured over 100 yards of lean concrete to get back up to the bottom of the footing.
What's that?
For instance, right here, we dug down 16 feet
To get to the bedrock,
to get to the bedrock.
16 feet. Wow.
I'm confused with what is the footing? What's the footing?
16 feet is close to 1.5 story. The story is about 10 feet, small story. So it's about 1.5 story. Built 16 feet to get to the bedrock. This is the footing.
Yeah. So that guy is standing down there to the top of that metal is 14 feet 8 inches.
So what is it? What is going to go up there?
So this is the loading dock. This is nothing. So it'll be a paved area where they can load materials and stuff into the building. So it'll have a small structure right on this end just to.
So are you going to put a slab?
Yes. Yeah. It'll be paving and concrete. So this will go as the footing steps down. So it's this last step in the footing. That'll be the low point of the loading dock. We'll have a drain in the bottom there. And it'll be the typical warehouse looking dock where they open the gate of the truck and it'll be able to go in.
So the truck will
Back
pass
down
through
there.
the.
Truck or something.